This video is on the objective. Calculate the margin of error for confidence intervals for a proportion. And this is number 1, so this is the first video on a question related to this objective that we're seeing in your Newton Alta homework. Alright, so again, if you're unfamiliar with the topic, the objective, please, you want to see how they're doing things, click on more instruction. Look at their videos, their notes, their examples, and hopefully that'll help you out. Alright, so let's read through this. We got Keisha. Keisha wants to estimate the percentage of managers at her company that hold an MBA. She surveys 320 managers and finds that 70 hold an MBA. So we're asked to find the margin of error for the confidence interval for the population proportion with a 90% confidence level. All right, so if we were trying to make a confidence interval, to guess what proportion of the entire company, right? She only surveyed 320 of them. She didn't do all of them, right? And she's trying to use this sample to guess, make an educated guess, an interval of guesses as to what the population proportion, what proportion of all her managers have an MBA. All right, so let's draw out what's happening on a piece of paper. All right, let's get rid of the calculator for a second. All right, so we have this population of, of all managers at her company. And we have this, P. All right, P represents the proportion of the entire population of all the company's managers across the country, maybe even across the world if it's that big, that hold an MBA. So proportion of, all the managers, all, the whole population. With a master's in business administration, MBA. All right, now this is unknown. We do not know this, right? Because we're not given information about the entire population. We are taking a sample, right? She takes a sample of 320 of these managers and finds that, and again, now I typically use X to represent the number of successes. And in this particular problem, a success is having an MBA. So she finds that of these 320, 70 of them hold an MBA, meaning that the sample proportion, right, remember P hat or P prime, you might see P prime as well. Both of these mean sample proportion. So the proportion of the sample that holds an MBA is 70 out of 320. And I'm going to round this. Well, I'll probably just keep entering. Now this is, I'm going to simplify this to 7 out of 32, right? Because you can divide both by 10. So when I enter this later in my calculator, it'll just be 7 out of 32. Let's see what this rounds to. Get a decimal here. So 7 out of 32, or 70 out of 320. Actually, I don't need to round. I'll just write it all. 0.21875. So almost 22%. It's 21.875%. Almost 22% of the sample she took has an MBA. Now, remember that central limit theorem for proportions, right? By the central limit theorem for proportions, if I was to take a look at, every possible sample of size 320 and then look at their p hats, look at the sample proportions, all those sample proportions would form a normal distribution, would have a normal distribution with a mean called, mu p hat and a standard deviation called, sigma p hat or sigma p prime. And, the mean mu p hat, the mean of all these sample proportions, would be the population proportion. But there's a problem with that. I don't know what this is, right? We're guessing what the population proportion is. So we estimate this with our sample proportion, 7 out of 32. We're using that as a point estimate of P, right? Our initial guess as to what P is. And the standard deviation, or the standard error of these sample proportions, remember, is the square root of P times 1 minus P, all divided by N. But again, I don't know what P is. So we're going to approximate this with P hat. And we're going to use our point estimates here as well. So I'm going to approximate this with the square root of 7 out of 32 times 1 minus that would be 25 out of 32. And then all of that divided by the sample size, 320. All right, so I'm going to enter that and round it or whatever. So I take the square root of, and I'll just take the previous answer, right? That was the sample proportion, 0.21875 times, and then in parentheses, 1 minus the previous answer, and then all this divided by 320. Right? Make sure all of that is in the square root though. So our standard deviation for the p hats is approximately 0.0231. Right. Now on the calculator, because I know I'm going to be using this value more times than not, I'm going to store this value, hit stow as x, and hit enter. Now every time I use the letter x, it's that standard deviation. Wonderful. And now I'm going to also draw a picture of this distribution. All right, we said the distribution of these sample proportions for samples of size 320 is normal. So there's a number line representing possible values of these sample proportions for samples of size 320. So it was normally distributed, so I'm going to draw as best I can a symmetrical bell-shaped curve underneath the peak. Now this should be the value P. This should be the population proportion. But again, I don't know it. So I'm using the sample proportion, 0.21875 in the middle here. The 7 out of 32, this guy. That's in the middle. Now, we are asked to find the margin of error when we're creating a 90% confidence interval in this particular question. So my confidence level is 90%. So what does that mean? In my picture, that means I'm, from the center here, I add, this margin of error. So I take, 0.21875 plus some margin of error, ME, and do the same thing, subtract that same margin of error, 0.21875, minus the margin of error. And I want to figure out what the margin of error needs to be. How far away from the to the right and left of the center do I need to be so that the area between them underneath the curve is my confidence level, right? This area here is 90%. All right, well, in order to do this, all right, in order to find this margin of error, right, how far is this? What's ME? I need a z-score, right? This is a normal distribution. So when we talk about I want to talk about how many standard deviations away from the center are these two values, this upper value and lower value of the interval. So I need a z-score. And you probably recognize this from when we did confidence intervals for a mean, right? Instead of for a proportion. It's a z-score with an area of alpha over 2 above it. And we'll talk about alpha in a second. Times the standard deviation of the p hats. So again, here's the formula for the margin of error when you're creating a confidence interval estimate of p. You have some z-score with an area of alpha over 2 above it, times the square root of p hat times 1 minus p hat divided by n. Right? That was the standard. That was I used p hat instead of p, right, to estimate that standard deviation of the proportions. All right. So what is this alpha? And what is this alpha over 2? So remember, if there's 90% in between these values, alpha, it's what's remaining. Another name for this is also called the significance level. You don't need to know that for right now. What's left over is 10%, or 0.1. So that means this area above, right, this little blank area here above, and this little blank area here below add up to 10%, meaning they're 5% each, right? And that's the alpha divided by 2. All right, 5% or 0.05. So the z-score of this upper value has 5% above it. So we're looking for this value right here. What's the z-score with 5% above it? Now you can find this a couple ways. Now they're asking us to use the chart. They gave us a little chart with some special z-scores on it. And the z-score with 5% above it is this 1.645. All right, so this is 1.645. And all this means is that this upper value and this lower value of the confidence interval are 1.645 standard deviations. 1.645 of this above the mean and below the mean. And that 1.645 standard deviations is the margin of error. Right, so the margin of error here is going to be 1.645 times, the standard deviation, which we saw earlier was about 0.0231. So let's enter that and approximate it. All right, so I got my calculator ready already. So I'm going to take 1.645 times, and I'll just do the previous answer. I don't know why I stored that as x, because the previous number, this 0.0231, that's the margin. That's the standard deviation. So I'm taking 1.645 standard deviations, and this is your margin of error. And they want me to round to 3 decimal places, so 0.038. All right. So this value, this upper, now if I was making the confidence interval, I'd take my point estimate, 0.21875, and add 0.038 for the upper value, and subtract 0.038 for the lower value. And then we'd be like, hey, okay, I'm 90% confident that the population proportion, right, the proportion of all her managers that have an MBA is between these two values. But we're not asked for all that. We're just asked for this margin of error, this z-score times the standard deviation of 0.038. Right, and that is all. Again, please read the answer explanations, whether you got it right or wrong. Now you see how they're using p prime instead of p hat sometimes. No big deal. They're the same thing. They mean the sample proportion. And yeah, so show you the calculation there. And that's it for that objective, right? That's it for that kind of question. You're going to see that kind of question for that objective. So hopefully this video helps you out. And I'll probably have another one after this related to another question on this. It'll be a little shorter because I won't draw all the pictures. I'll just probably use the formula next time. And hopefully this helps. And thank you very much for watching.